We'll look at some more examples of how we compute the big O of different functions. So the goal of this slide is to look at a bunch of functions, and the job is to identify whether these functions are big O of x. If they are big O of x, then identify possible values of c and k. Note that these values may not be unique. You could have more than one values. I have the answers on the next slide, uh, but I would ask you to pause this slide and do this yourself before you go to the next slide, or you can pause it on the next slide so you look at answers for some of the problems but do some of these uh, by yourself. So I have fx is equal to 10, 3x plus 7, x squared plus x plus 1, 5 log x, and floor of x. So here are the answers. I will keep this slide for a little bit just for you to look at. Review the answers, see if they make sense. Again, these answers are not unique. In fact, I would highly recommend you to try to find alternate answers so that you can see how you go about finding C and K. The next thing we want to look at is find the smallest integer n such that f of x is big O of x to the power n. Once again, the answers are on the next slide. I would recommend you to pause this slide so that you can review and do it yourself before you go to the answers. This is the slide with the answers. Please review if it makes sense. If something doesn't make sense, this is something we should discuss in class or on PHR. Our next example is to show that n to the power m is big O of 2 to the power n, where m is any integer. So in other words, n square is big O of 2 to the power n to the power 1000 is a big O of 2 to the power n, and so on. Once again, knowing log n is less than n would be useful to do this. Here is the proof. So we are going to start with this expression, log of n to the power m to the base 2. First thing we are going to do is we are going to take this m, take it out, so that is same as m log n to the base 2. I'm going to write n as square root of n square, so the term will be m log square root of n square to the base 2. We're going to take this 2 again outside, so it will be 2m log square root of n. Now I'm going to replace log square root of n by square root of n because I know that log of square root of n is less than square root of n, and that's why I have a less than introduced over here. I would suggest to pause the slide here to make sure that you are comfortable with this particular line of the slide. Next, we are going to write square root of n as n divided by square root of n. Then what we are going to observe is we are going to take this term 2m square root of n divided by square root of n. I'm going to observe that this is less than or equal to 1 if I choose n to be large enough. Note that m in this example is a constant, n is variable. So if n is large enough, I know that 2m divided by square root of n is less than or equal to 1. So I can write log of n to the power m to the base 2 is less than or equal to n when n is large enough, where n is greater than or equal to 4m square. The next thing that we have to do is basically put both of these and raise it to the power 2. So I'll get n to the power m is less than 2 to the power n, where n is large than 4 times m square. That means n to the power m is big O of 2 to the power n. A couple things to note about this. These are what we call polynomial functions because they are polynomial in n. M is a constant. These are exponential functions because in this case the n is in the exponent rather than as a polynomial. What this result shows is exponential functions grow much faster than polynomial functions, and this is true even if the polynomial that you're looking at has quite high powers. Like even if I have n to the power 1000, it is eventually going to grow slower than 2 to the power n. Here is the big O hierarchy that you should familiarize yourself. So on the low end we have 1, then we have log n, then we have powers of n that are less than 1, so that's fourth root of n, third root of n, square root of n, etc. Then we have n log n, n square root of n square, so on and so forth. Then after the polynomials come the exponential functions, then we have factorials, n to the power n, etc. Once again, we have reached the check before you go ahead slide. I want to see if you can show that the function x squared plus 3x plus 7 is big O of x cubed.